Hello everybody and welcome back to the Code Wrinkles channel for a new live coding session. I guess it's been around 10 days since the last one. I'm really sorry for that. I really wanted to make this session earlier, but unfortunately it was not possible. But today I think we'll do some very exciting stuff, and I have to admit that what we'll do today is actually fairly new also for me. And I've been given a lot of thinking about, okay, what should we do next? And right now, if we look through our vector data type that we have created already, we can see that, well, we have implemented some very cool stuff, like we have the constructors for the vectors, we know the dimension, we calculate the magnitude, we have implemented the indexer, so we can actually do we can access the elements of the vector by their index, which is fairly nice. And then we have done a bunch of overrides and implementing different interfaces, like iEquality, for instance. We have this equals, the object equals that we have to override, then the get hash code that we have to override when we implement equality. Then we have some mathematical operations on vectors. We have implemented some where we can add two vectors, in this case the current vector plus a new vector that we specify here as an incoming parameter, and then we can calculate the sum by simply providing vector 1 and vector 2. And of course this one is static because we don't actually need a vector instance in order to be able to calculate that sum. So this is fairly okay, I guess. And then we have the scalar multiplication, where we multiply a vector by a scalar. In this case, our scalar is of type int, but theoretically it could be actually, or it should be able to be actually, or virtually everything. Like, I don't know, it could be an int, it could be a double. In fact, I guess we'll have to implement overloads for this one. So that we'll have scalar multiplication with integer, then with double. And I guess that should be fine because double covers also the floating point numbers from minus to plus, so that should be okay, I guess. Then we have a scalar multiplication, which is a static method where we provide both the vector and the scalar value, and we do actually exactly the same thing. And then we create a dot product, and we discussed it when we talk about vector multiplication. There are actually two different concepts, like the dot product, where you actually multiply each element of one vector with the corresponding element of the second vector, and we return the result. Then we have a static version for the dot product, like for all the other operations. And then we have implemented the IEnumerable interface so that we can do a for each through our vector, which is okay. Then we have implemented this equals method from iEquality, and then get hash code, and then to string, and then we have operators like equals, not equals, plus, and the product. These are all the things that we have done so far. So we have a fair amount of features, I would say, on this vector. And there is one thing that was bothering me, I would say, for the last couple of days, maybe even more, because what I want to do is actually to be able to, well, support a generic vector. But the problem with supporting a generic vector, as I said, that won't be easy at all, and actually it's the first time that I try to do something like that, is that we actually want to support only numeric types. And the problem is that we cannot simply say here vector of t and then where t inherits what, because we cannot specify that. And this is a very, very big problem, because we will have to create a lot of stuff around this idea of vector in order to be able to support this generic version of it. And yeah, that's kind of yeah, a little bit problematic, I would say. But let's try to give it a go. I guess the only real way to go here is to use generics. If you, by the way, have a different idea on how to do that, then just please let me know, because I don't exactly know how to do that. But the idea is that I want to have a generic vector. So we would have a struct which is vector of t, and then the I equatable should of course be I equatable of vector of t. And of course right now we have an error here because this interface is not implemented anymore. So we would have to change different type of things, and we have a lot of errors right now. So we'll basically have to go through each of them, but the most problematic aspect of this will be actually the mathematical operations, because we will have to handle them differently based on the scenarios that we have. So we would have to check the type of t, and based on that type of t, we would actually need to use different calculators, one for integers, for instance, and one for doubles. And let's, for now, only support integers and doubles. The challenge with this approach here is, when I want to use generics here, is that I cannot say here, for instance, where t inherits, I don't know, number or something like that. Now in JavaScript that would be possible, for instance, but not in C#, and there is actually really no way in order to restrict this t to be a numeric value. So we will have actually to handle this type of stuff in our code. So the first thing that I would like to do here in this case, so as we have everything generic, the field that we have here, it would be a t array that contains elements. And then for the constructors, of course, we would have to also change that. So we would have a list of t, and then the get magnitude method has a problem because, yeah, we would have, or we would need here a t element. And the problem is right now that with this t element, it doesn't know exactly that this is a number, and this is probably argument cannot convert from t to double. Okay, but why does it try to convert it to, because it's double here. Okay, so that would actually be very, we will have to see exactly what we can do there. But we will have to specify here that t is actually a double. Maybe we can just try to cast this. And I guess that should work. Oh, no, it doesn't work. Cannot convert from type t to double. Okay. Because if we have an, if t is an integer, then theoretically we would have a way to convert it to double. But if yeah, I guess we'll come to this just a little bit later. But I'm thinking right now we would have to var, let's call it a double, or a var, let's do it like this, converted element equals, and convert to double element. Of course you would have to, and in that case it would be okay. So we can just use this one, and right now this get magnitude method should actually work. So one of the problem is already solved. I guess that was the, I guess that was the easier one. Okay, exceptions. Okay, so here we well, if we get an exception, we should probably just rethrow it. So yeah, right now we are not doing any logging, but if an exception is thrown, then it should be thrown. The consumers should then maybe think about that. But yeah, probably we'll do also later some more fancy exception handling here. Okay, so right now we have solved this one. Now for the other constructor, it's exactly the same thing. We would have this t array and the elements.length, and everything should be fine with the constructor. But then if we go further, this won't be of type int, but it should be of type t, I guess. And that should be okay with the indexer. But we still have some problems here. Let me just 1 second. Okay. So we have fixed the indexer, and now we have this equals, where we would have a vector of t v1 and vector of t v2. Okay, and then this calls this other equals method, where we get in actually an object. And here, this check that we would have to do is the object is not a vector of t. Then we will return false. And then v1. So this should be the v1 then. I would try to cast it to a, I don't know, vector of t. We'll see later if this really works. But right now this v1 would also be a vector of t, which is okay. So if we go to this other equals, okay. That's actually calling itself. Well, that's something that we have to change, I guess, at some point. But right now, I just want to concentrate on what we want to do today. Now, the hash code, we're just going to return this get hash code object as a vector of t. v1 is then we cast it to a vector of t. Okay. Then hash sum elements in v1, hash sum element get hash code, which should be okay. So this one should be fine right now. Okay, let's start from the beginning, where to get hash code is okay. And here we are at this sum. Okay, so first of all, we would return here right now a vector of t. Now, the problem is here that we won't know exactly what t we should actually return, which is kind of like a problematic. And here we will have a vector of t. Good. Now, when we check the dimension, that's exactly the same as before, so this doesn't actually change. But then the problem is here that we have calculated everything thinking about the vector as being a vector of integer. But right now, this vector can be generic. So the idea is that when we calculate the sum array, we don't exactly know if it should be, I don't know, int or double. So we can say that, okay, it could be an array of t. And that should work. So that is not really a big deal. But what it is a big deal here is, for instance, that what we want to do is here in this sum, we'll have to add this t and this other t. And as you can see, operator plus cannot be applied on operands of type t and t, because it actually doesn't know exactly what to do. What t actually is. Is it a numeric type, or is it not a numeric type, and so on. So yes, How should we maybe proceed here? How should we proceed here? I mean, as we did for the equals, you would have here actually to convert the t to a certain type, but we don't know actually exactly what the t is. We can do a check, of course, and have, I would say, or a switch, and get the type of t, and then based on the type, actually calculate if that t should be doubles and cast it to double, or it should be integer and cast it to integer. Okay. I think I have an idea on what to do here. So I guess we'll go a little step further and we'll introduce some other classes. Like what I think is that we could have a class that should be a vector calculator, and the responsibility of doing different calculations on vectors or on generic vectors should be on that vector calculator, and the vector calculator should then implement a logic to actually understand or define if we have to create integers or if we have to create and add doubles and things like that. And I guess I want to have this vector calculator directly here. So let's add a new class. Okay, let's call it vector calculator. Let's make it public because consumers might even use this class actually to perform calculations on different vectors. So I guess that's kind of nice, but I would say, because this is more something, I would do this class as abstract, but I won't really do that because I want that consumers should also be able to create a new instance. But it's actually also a good candidate for a static class. Let's see if we can implement this in a static manner. But in this case, what I would like to do here is I would add a new folder, and I will call this folder abstractions, because in this case I want to expose behavior through an interface so that consumers or other calculators of different type of numbers would actually behave according to the contract that we define in the interface. So yeah, let's add a new class. Let's choose interface here, I vector calculator. Okay, and this interface, let's make it let's make it public. Okay, so what we will do here is, first we will have we'll have one method, let's call it vector. It will return a vector of t, and here it would be sum, and we'll have here a vector of t v1 and vector of t v2. I guess in order to be able to do that, we should do this way. Okay, so now we will have a sum. If we use a calculator, then I guess we should actually move all the calculations that we have here in this one. So what we will also have is a method that returns a vector of t, and this would be scalar multiplication, and then here we would have once again a vector of t and a scalar, and this should be, well, what data type should the scalar be? Because if we do scalar multiplication, you know what, we'll have here once with int, it could be an integer and it could be a double var this is v1, and then vector of t scalar multiplication, okay, vector of t v1, and this time the scalar would be a double. Okay, so we have an override for that. Then what we would have to implement is another method that returns a vector of t, and that would be the dot product. And to calculate the dot product, we actually need here a vector of t v1 and a vector of t v2. And that should actually be it. Now this is then the interface, basically our contract. Okay, now we have this vector calculator, and the idea is that, as said, we would actually I'm thinking about here, this is if we have a vector calculator, I mean, if we don't make it static, then we can use also here t. But what I want to achieve is that I'm thinking about, I want to have a vector calculator, and that it exposes all the needed methods to do all the possible calculations on vectors. So I wouldn't really want to make this class generic and to instantiate an object of it. I would really just like to be able to call different operations statically, and then having maybe a strategy to define based on the type of t in the vectors how exactly to proceed. So yeah, but you know what, I guess what we could do here is because if I implement here this interface, I vector calculator, then I would have to make this generic also. Okay, and I wouldn't like to make this generic. But maybe that's actually a good idea. And here, of course, we would have to implement the interface. And still, I think we can do this statically. So let's make this static. By the way, guys, if you have any questions or if you have any ideas, if you want to say something, just get in touch with me. Please don't be shy and use the chat. It would be very, very highly appreciated to know that that I'm not talking here with really no end product, so to say. So yeah, we have, let's make this static. It would be vector of t. It will return dot product static vector of t. Here this should also be static. Okay, this is scalar multiplication, and this should also be static. And I guess we'll start with implementing this sum. Now, what we could do here is, for instance, let's just not throw this exception here. So var t type equals t dot get type dot name. This should be a method, I guess. What is the problem? T is a type parameter which is not valid in the current context, in a given context. Why is it not valid? I guess because we have to actually v1, let's make it like that, var v1 t type equals, and we can say here vector 1. We can use the indexer, look at the element at the first position and run a get type on this one and use the name for it, and this should display the name. Okay, then let's have var v2 t type equals v2. We can once again check the first element of the vector, get type and name. Right now we have information about what type of t we have. Now I think right now we could do, or we could support different scenarios. Let's say we want to support integers and doubles. So in this case, we would have actually two different ways of doing that. On the first way, we would need a calculator that would calculate based on int, and we would have a double calculator that will calculate based on double. And based on this type, we should use the one calculator or the other. So yeah, we have this, I would say, vector calculator, which should be exposed, should be public. But then we have, let's add a new folder here. New folder, calculators. And let's add new class, vector int calculator. And I would like to make this internal, because I want this to be visible only in this assembly. So it would, this one would implement I vector calculator of int. So in this type, the t will be an integer. Okay. And I guess this class can also be static. So it would be, of course, we would we will have to implement all these type of things. Public, static, once again static. Of course, I have also to type it correctly. So yeah, right now we should be good. What's the problem though? Static classes cannot implement interfaces. Okay. Let's not make this static. Okay. Vector calculator does not implement interface member I vector calculator of int sum. Okay. Vector calculator sum vector int cannot implement interface member because it is static. Okay. That's actually true. Yeah, correct. That's actually correct. And that's actually the same problem that we have here. So since we want to make this generic, but maybe we can do this differently. I mean, this concept with the calculator, I think it's still a good call. So we have a general purpose calculator, which could be generic, but then we have different calculators that are actually not generic by themselves. So yeah, Okay. But in this case, everything should be okay, or it is not. Static class cannot implement interface. Okay. Yeah. Okay, we have a static class, but okay, but right now, yeah. So in this case, we would need, I guess, an instance. I guess we would need an instance for this one. Yeah, let's first try out the concept and we'll see afterwards if everything's, or how we can expose this maybe statically somehow. But let's see that conceptually this approach with the different type of calculators works correctly. But that still gives me an error message. Okay. Static classes cannot implement interfaces. Yeah, but this is not static anymore. Nothing is static anymore here. Did I maybe miss something? Okay, I guess in the interface. No, in the interface, everything should be actually fine, I guess. It's just the I vector calculator of t. Maybe we should also expose an I vector calculator which okay, let's maybe try this thing right now. Let's say first of all that this vector calculator doesn't implement this at all. So we just have a regular class. Public class vector calculator. But I'm not sure what happens. I guess Visual Studio goes crazy or something. Yeah, correct. But then in this case, we cannot, yeah, we need to specify a t for the calculator. Let's clean the solution because that's, I'm not sure exactly why IntelliSense it's causing problems right now. Because right now maybe I vector calculator of t. Maybe this is also the reason why we got that error message. Let's clean solution. Okay, so right now we don't have this error anymore because nothing is static anymore, and this is okay. Good. So right now let's go back here to the sum, and so we have the type. Now the idea is that we need to define exactly what type of calculator should we actually do. We have here a vector int calculator. Let's also kernel class. Let's do cleanup here. Okay, let's remove the static keywords from here. So this should also work fine. Okay. Right now I will, let's just redo a cleanup. Okay, I have vector calculator of int, t is int. Okay, what is the problem though right now? Because, okay. Just Visual Studio that is very, very slow in this case. Good, so we have this vector int calculator, and let's create a new one. And let's create a new one. Class vector double calculator. Public class implements iVector calculator of type double. Okay. But I'm not sure exactly what's the problem with this. With Visual Studio right now, it's really acting weird. Of course, now I have to add this using, but even if I have added this using, it's still a problem. It's very slow. The entire Visual Studio is very, very slow. I'm not sure what's actually wrong with it right now. No, it simply very slowly picks up everything here. Right now, it doesn't really pick up that we have implemented the method here. Yeah, it's slow, very slow. But yeah, let's I don't know. Okay, but it still complains about something. No, it doesn't. It's just slow. Good. So let me then, so we have these two type of calculators. Now here, this is actually where we will calculate different type of things. But in order to be able to calculate something in this vector calculator, we should first of all, where is it? This here. So based on this type, we should actually do a few things. So first of all, check the type of the t. So what is the type of t actually? And if it is an int, we should use an int calculator. If it is a double, we should use a double calculator. And if, for instance, the type of t is here, so maybe if the elements are of different type, then maybe we should by default just use the double calculator, I guess. So we have these three scenarios. So in this case, let's try to do the following things. So if let's create a switch, but a switch on what? I guess maybe with switch it's a little bit more difficult. So if v1 the type so this is already the name equals, and let's see system dot int 32 dot it doesn't but I guess here it should work with the name of probably. Found missing using directive. Okay. Maybe like that. Int is a type, but I'm actually not using int at all. Okay, so yeah, this is the int. Okay, but I can do a name. Okay, so let's try to hard code it right now. So if this one is system dot int 32, so in that case what we'll do here is we'll use an int calculator. But in order to use the int calculator, because we get this as keys and we will have to return the keys, so what we will have to do, like the steps is first of all we would have to convert. So let's see, first convert v1 and v2 to vector of int. Then we use the calculator to calculate the sum, and then so this would be the second step, and then the third step would be to convert the sum vector to vector of t, because we have to return that as a vector of t. Hello Ashan, thank you very much for watching. What do you think about what we're doing so far? Do you have maybe a better idea on how we could achieve this type of support of only numeric types on our vector data type? If you have any thoughts about this, feel free to just let me know. Okay, so, and here we see that we will have this step 1 and step 2. We have this convert. Here in this case, we would have to convert the vectors to a vector of int. And here we would have to convert the sum vector to a vector of t. So I guess we'll add a new folder here. Add new folder. Converter. Maybe we'll use different type of converters, but for now, let's just add one. I guess this one will be able to implement statically. But actually, this should be maybe vector type converter. Here, let's rename vector type. Yes, just rename everywhere where I have used that. So that should be okay. And here I would also like this to be internal. I just want to use it here in this library. I don't want this to be used. Okay, what about using type of system int 32? Yeah, that's actually, I guess, a good idea. Let me go back to the int converter calculator. It should be here, and yeah, let's type of system int 32 dot you say it should have a property full name. I guess name. If we use the name here and if we use the name here, I guess it should be the same. Let's try to do a cleanup. I'm not sure exactly what's wrong with Visual Studio right now, but it gives a lot of errors. Okay, name can be simplified. Okay. Yeah, but it still says that name can be simplified. Convert type of to name of. Okay. Let's just do a cleanup once again. Yeah, it works like that. Cool. Okay. So in this case, we should be good to go with this one. So thank you very much. Thanks, Shake. Thank you very much. Good. So let's go then back to the where were we? To the vector type converter. And here, right now we are actually what we want to do right now is to be able to convert from t to int and from int to t probably. So let's do it like that. Internal. I said I want to have this statically. Internal static. What will this return? It will return a vector of int. Let's name this convert from t to int. But the problem is here, once again, that as we use the idea of t, we'll need to provide probably, let's clean up. Okay. No, of course, I'm not returning anything right now. So I want to convert from t to int. And in this case, I would need here a vector of t. Let's clean it again. Hello, Fright. Lol from Twitch. Thank you very much for joining. Okay. Of course, this t at the time could not be inferred. Okay, but here, where a t, well, it should be a struct. Still nothing. No, they cannot infer that. Okay. So we return a vector of int. And we should be able to get here a vector of a numeric type that is different than int. In our case, probably double. Or actually, we just need to okay, but maybe I'm still thinking. What would be the best way to proceed. Because actually I need just a method where I can get a vector of a generic type that I don't exactly know and just return a vector of type integer. That's what I want this type converter to actually look like. So in this vector calculator here, for the first step, I just want to provide it with v1 with v2, and I want it to output to me a vector of int v1 and a vector of int v2. This is actually what I wanted to do. And for that, I just wanted to move this logic for conversions into a different class. And that's why I created this vector type converter class, which actually here I want to convert from t to int. Maybe if I provide here that I want a vector type converter, for instance, from t of type t, okay, so right now at least few of the problems are solved, because I want a vector type converter that I would use, for instance, as a double, and I would create and I will turn this to integer. So okay, so what I would like to do here is then, of course, create actually a new int array, int vector. Let's call it int v1. Okay, int v1 equals new int array, and we'll have the dimension as the length. And then what we can do is we can use a for each of our element in v1. I want to go through each element, and here I would just want to actually what I would need here is a for loop. For int I equals 0, int I is less than int v1 dot dimension, for length in this case because it's an array already, but I can also use the v1 dimension if I want to, but in this case it's I'm counting against that one, and that is already of the same length as the dimension. And then of course we increase the counter, and each time we are here int v1 of I equals, and here I would say it should convert dot to int, and I want to convert to int the v1 of I. Okay, good. And then can return new new vector of int, and I specify the int array. And if I clean up once again the solution, I would have expected okay, but I don't see any error right now. So a comment here on YouTube: hi, I am still very new to C# but still seeing this video so that I can get some grasp on it. Yeah, I guess that really could be helpful, because, well, you see here in this case some of the problems that that we face actually when we try to implement a custom data type, and we go through different concepts actually through, I don't know, from generics to interfaces, to loops, constructors. We basically touch off everything, so I guess that might be useful. Okay, but I'm not sure exactly why do I have this, why is this underlined? Why is this still underlined? Let's do a new clean solution. Yeah, of course. It's just Visual Studio going crazy. Because right now we have this, okay, so let's do also the other way around. Int static here will return a vector of a double and convert from t double. And here we have a vector of t which is v1. And I guess we can actually reuse this, but we'll just have to change the data types. So here we will have a double array. Here maybe let's change this name to double v1, and it would be new double array. Okay, and then once again we loop through the vector that we receive, and we just don't want to convert to int 32 but to double. That should be okay, and then we return a new vector of double. Okay, and right now let's try to do it the other way around. Maybe here internal static, and here we return a vector of t, convert from int to t, and here we get, for instance, a vector of int, and here we will actually the procedure would actually be fairly similar to what we have here, only that in this case we will have to do it the other way around. So we will have a t array, and it would be a new t array, and then for each of those, I guess I'll have to clean this a few times because I want to see exactly where I still have errors. So okay, in this case the convert doesn't help me at all. So what I can do instead is, and that's a little bit tricky, I cannot cast my integer directly to t, but I can cast t to object, and then I can cast this to my v1 of I, something like that. But then let's also change the naming. This would be a t v1, and then t v1. Okay, and here I would have a new vector. That's strange, because for a new vector I would have to specify a t here. T v1. Let's do a clean to see exactly where we still have some real errors. Okay, we have an error here because we have changed the name here. Name should be t v1. Okay, and right now this shouldn't return an error. So in this case we are providing a vector of int, and we return a vector of t, and that's very similar to this one. We'll do it also for the double. We'll have here internal static vector of t, so we return a vector of t, and here convert from double to t. And what do we want to convert? We want to convert a vector of double v1 to a vector of t. And here everything would be similar. Actually, it would be the same, I would say here, because I just want to cast this double to the integer. Let's just do a cleanup once again. And I'm really not sure what happens with Visual Studio right now, because it's so slow. Okay, but what is the problem here? Because that okay, we have also changed the names here. It is double v1. Sorry for that. Double v1, and here is double. And by the way, in the description of this video, you will find also a link to the GitHub repository where I push all the changes that we do after each live coding session that we have. So if you just want to check the entire solution and the progress, then you can just clone that repository, and yeah, if you can't attend the live coding sessions, then you may just want well, to do a sync from time to time to see if we have something new. So yeah, let's clean the solution, but of course here we also have to change the name to double v1. And let's clean it again, because right now it shouldn't be any error here. So yeah, I'm really happy right now, because what we achieved, we have here a converter, which is fairly cool. So let's see how we can use this converter in the calculator. So we see that if v1 type equals name of int 32, in that case, first convert v1 and v2 to a vector. Okay, so we can have here var int v1 equals, we can use the converter vector type converter, and it should be a generic one. Let me just go here back to the vector type converter. Where is it? So it is a generic, so we get the t here, and here we get an integer. Well, that's kind of funny, but we'll see if we can change this. So we have a vector type calculator of int, vector type converter of int, and then I hate this because it's very hard to code without IntelliSense at all. Let me do a thing here. I will briefly talk here just a little bit, and in the meantime, what I will try to do, I will just restart my Visual Studio, because maybe a restart will do it. So yeah, let's just wait. So I guess this from a conceptual perspective, this idea with the type converters and the different calculators, I guess that's actually that's actually a good approach. I'm not sure though if our implementation is really the best possible one. I'm sure it is not, but yeah, it's something that we could improve maybe in future if we come up with different new ideas. So Visual Studio is still restarting, but it's still very slow, and I'm not sure exactly why this happens, because we hadn't have these problems so far in none of the live streams that we had. So Just give me just 1 second. Because it's actually worse now with the restart. It doesn't show anything right now. Everything is just white and blue, which is very, very unfortunate. Okay, so I guess I'm fairly sorry for that, but I guess we'll have to pause for today. And I promise you that we will continue to work on this one as soon as possible. Probably not today because it's fairly late where I'm living, but I hope that tomorrow we'll be able to just continue and implement this idea with the vector type converters and everything related to that. So yeah, this being said, thank you very much for being here. Thank you very much for dropping some comments. I'm really happy that you were here. I'm sorry that we weren't able to finish it today and to implement these concepts of supporting different vector types, but I'm confident that we will finish this tomorrow. Once again, thank you very much, and until the next time we meet, please take care of you and have a nice day. Bye.